Morning. De La Rosa. That's a pretty way to spell Abigail. I don't care about that. Okay. Morning. Okay, y'all. So today we start 3.4. We don't start it, we're gonna do 3.4. It actually ends the material for exam 2. So what's today? Tuesday the 7th? What? That's not right. The 28th. So this Thursday we'll do a review. I wrote on my hand review. I know I have one typed up somewhere in my computer. So during my office hours, I'll find it and make sure, it includes everything it needs to, and then try to email it to y'all. But then on Thursday, I'll have them printed up so that we can all just kind of work on it together. You don't have to turn it into me, but that way at least you have a review, which means a week from today, next Tuesday, the 7th, will actually be your exam 2. For 3.4, we're going to do a PQR truth table. So it's one of the larger ones. Our goal is to figure out whether or not statements are equivalent. And for statements to be equivalent, it means the answer columns are the same. After we do that, we're going to literally write out sentences, real sentences about tires being flat, so that we could see something that's called De Morgan's Law. And then I look at Peter because, yeah, we talked about that before. And then after we do that, we actually have the different variations of our conditional statement. That's the if P then Q. There's actually 3 different ways that you can write them. And then that'll be it. So let's go ahead and get started. Maybe. There we go. Okay, so 3.4, it's just titled equivalent statements. Let me change. Fingers are swollen for some reason. Nope, that ain't gonna work. 3.4 equivalent statements. And technically everything we do today is all about equivalent statements. So I'm going to kind of do a little sentence or two explaining what equivalent statements are. Okay, so equivalent statements. It should kind of be self-explanatory because the word equivalent is literally in the title. We're going to talk about first how they're symbolized. So whenever we talk about, sorry, my word symbolized the word. Whenever we talk about statements being equivalent, there's notation that we could use, which is a double pointed arrow. But instead of just one horizontal bar, there's 2. If you see that in between 2 statements, that's you saying these statements are equivalent to each other. Okay. Or in math, equivalent could also be denoted by, instead of it being an equal sign, you just add 1 more horizontal bar, and that right there means equivalent. Okay. And so this is when both statements have exactly the same answer column. So it's the exact same truth values in their answer column. And it doesn't matter what way they go. It could be true, true, false, 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 true. It could be true, false, true, false, true, false. As long as both of the answer columns completely match, those statements are considered equivalent.
So you're saying if there's Three falses and three true. The other one has to have three falses and three.
in the exact same order, not just 3 and 3, but literally because whenever you do it, like when we do this example, it's just one big PQR. We do what the PQR cases are, and then we're going to have one statement, and then we're going to have another statement. You work on both of them, and at the very, very end, whenever you get your answer column, they have to match completely. Not like, oh, this has 2 truths and this does 2. I mean, it literally is like in line with each other. And if that happens, you just state that those statements are equivalent. Okay, this is also known, especially in this section, like in this class. And I write this so that if you see this word on like an exam or something, you know, but it's like logically equivalent is what we say, because we are doing the logic section right now for this book. Okay, so the answer columns are exactly the same. There's no difference in them at all. Those are the 2 symbols that you could use. Like if the exam says, are these 2 statements logically equivalent? You could write the statement, you could do the symbol, and you could write the other statement. That would be you telling me that, yes, they are equivalent. That's like how you could use those symbols, okay? So let's go ahead and do this big PQR to determine whether or not these statements are equivalent. And then after that, we do kind of change gears. I don't know why I had to go. Let's do it. So we're going to determine if these are equivalent. So let's just do our P and our Q and our R. I'm going to go ahead and do a line that goes all the way across. And then I'm kind of splitting this larger area into 2, because right above there, that's where I'm going to put the 2 statements that they give me. The first statement that they give me is P and open Q or R. And then the other statement is open P and Q close, or open P and R. So it's like, technically I need to get the answer columns for both of these. And then the goal is like, if they match, they're equivalent. If they don't match, you just say that they're not equivalent statements. Okay, so I'm going to do in all black what we would be given. Like technically this isn't something that y'all need to memorize. And then I'm going to change colors to actually do our work. Personally, I would probably just like finish one statement and then go to the other. It just makes the most sense. With this example, nothing's being negated. And so with the first statement that we have in this 4th column, what I would do is probably just like copy the P, and then I could work. Well, no, I'm going to do like I always say, let's work inside the parentheses first, because we're in math and like usually do those first. And if you notice, this is just a simple connective of the word or. And so this is asking me to look at the Q column as well as the R column. And I'm asking myself, is this truth value or this truth value true? And so where I'm looking is right here and right there. And I'm going to do one row at a time. So you say, is T or T true? And because they both are true, what you get for your outcome is that, yes, at least one of them's true. And then you say, is T or F true? Yes. F or T? Yes. Right here, this 4th case, if you ask yourself, is F or F true? Either of them? No. You get F as your answer right there for your truth value. Is T or T true? Yes. T or F? Yes. F or T? Yes. F or F? No. So that's like the first column that I would work on, and that's like the answer for that parenthesis, for that work right there in the parenthesis. So that's the first thing that I did. And then I'm just gonna go ahead and copy the P. If you have the ability to look in your P column and do this answer right here, that's fine. A lot of people can. And it is just an and connective, so like you don't have to worry about order or anything. But I'm gonna go ahead and just kind of copy it, because that is what right here it is telling me I need. So now that I've copied P and I've also answered that or connective in the parentheses, what I can do is now the and connective between these two, and then these two, and then these two, and so on and so forth, working my way down. Once I do that, that's my final answer column for this first statement. Okay, so if I do that, I'm asking myself, is this and this true at the exact same time? Yes, that's different than or, and they both have to be, or it's either or. Okay, and then I ask myself, is T and T true? Yes. T and T? Yes. T and F? No. Well, this one false, 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 false. Yeah, sorry, I didn't look down to see it yet. So this is the answer column. I'm going to highlight it in this pink right here. This would be the answer column for that very first statement that they gave me. It's 3 T's and then what, 5 F's? So if I answer this other statement in this last column, and my answer column is 3 T's and 5 F's, I say, yes, they are logically equivalent. When you look at them, they don't look like it. That's why you need to do the actual truth table to figure out if they are or if they aren't. There are some cases that we'll see today that you can actually say, they're kind of like theorems in a way. And you can actually say like, yes, by De Morgan's law, they are equivalent. But there's a lot of them that you will have to actually do the truth table for. On the homework, you could probably get away with guessing, but that doesn't help you practice. So let's do the other one. The other one, they're just 2 sets of parentheses. So I'll just start with the first one. This is an and with the simple statement P and Q, which means I'm looking here and here. And I ask myself, is this and this true? They both need to be true in order to get true. And so third case, fourth case, fifth, sixth, seventh, and eighth, those are all going to be falses, right? And that is just for the first part of the statement. But is T and T true? Yes. T, I can't do it that way. T and T, yes. T and T, yes. True and false, no. No, 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 no. And that was me looking in the very first 2 columns, far, far left, and then doing the connective and. Only the first 2 cases both had trues. So with and, the outcome was true. Everything else was false. And then now we can do this very, very, very last set of parentheses at the end, which is P and R. So you look at column 1 and column 3. T and T, T and F, T and T, T and F, F and T, F and F. We're looking at 1 and 3. And so same thing, is T and T true? Yes. And then right here is T and F true? No, because they both have to be true at the exact same time. Third case, T and T is good, so we do true. And then the fourth case is right here, T and F. Honestly, y'all, we got F and T, F and F, F and T, F and F. From this point on, they're all going to end up being false. So 1, 2, 3, 4, 5, 6, 7, 8. I counted them just because it's hard to keep them straight without lines. It is. Yeah. Oh, yeah. You have an A4 paper. Yeah. You need something with lines to usually help. So after we've answered both of those sets of parentheses, now we can actually do the connective. Where we go in between them, which is the final answer column. And then our goal is to compare them. If they match, then they are equivalent. Okay. So what I'm asking myself with this or is this or this true? Is this or this true? And remember with the or, it's either or both. The thing is, you just cannot have both falses. Okay, so is T or T true? Yes. Is T or F true? Yes. As long as you have one, you're good. Is F or T? Yes. F or F? No. F for F? No. F for F, F for F, F for F, F for F, F for F. I know. Tell me about it. And then let me write underneath here. We did this one first, this one second, this one third, which ends up being my answer column for that statement. And if you compare them, T, 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 F, 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 they might not look it, but both of those individual statements are considered logically equivalent because their answer columns are the same. That makes sense?
You write that. You write like P and open.
Okay. Do you want to know how lazy I am? I personally would call this one and I would call this two, and I would say that 1 and 2 are logically equivalent. Now you could do that, or you could quite literally write P and open Q, or write the whole thing, do one of the symbols and then write the other one. Okay, but if I see that it's like you've declared, hey, let's call this 1, let's call this A, right? And then you go over to the side and you write it, like that makes sense to me, because like that's what we would have to do. Like whenever I took classes like this. But putting them on the outsides of that symbol, like where that symbol's on the inside, is saying that it is equivalent. Or you could just write, yes, equivalent. It's fine. Like I'll take any type of variation as long as the answer is not no or false or purple, even though I love purple. That's not an answer, obviously. And then, oh, look, I just saw my own little shorthand. This is what I wrote, Peter. I said, therefore, yes, equivalent. After doing it, you see what I mean? Like there's so many different things that just looks like symbols, but after you hear them enough and you use them enough, like I'm saying right here, yes, those are equivalent statements. Like I've done this work, right? I've proved it. Therefore, yes, they're equivalent. Okay, there's a number of different ways that you can write it. Okay, so we did that just because that is a good practice. That was like our first example, kind of talking about logically equivalent statements. Now let's do this other one. It's a lot of writing. And then after we do all this writing, and then we kind of change it into symbolic form, we're going to answer each of the symbolic forms. And then whenever we notice what is equivalent, that's when you learn about De Morgan's law. Ow. Okay, so here's like the second example. And I did compare this in the homework. I'm pretty sure everything we do today, like the homework should be. At least I'm thinking I answer all the different problems. Okay, so what is logically equivalent to, and then we're going to do quotes. What is logically equivalent to? It is not true that the tire is both out of balance and flat. So it's kind of like we're going back to 3.1 with actually having sentences. Now I'm going to under here, because it's very similar to the homework, like it's not verbatim because my words are different, but the setup is the same. You're going to be given words and then you're going to be given statements in English. And then what you need to do is actually like state, this is P, this is Q, write it symbolically, and then you could look at it that way. Okay, so what is logically equivalent to? It is not true that the tire is both out of balance and flat. Here are the different statements that it wants me to decide what's equivalent. Okay, so I'm going to change to purple because I have purple in here. The first one that I have is if the tire is not flat, then the tire is not out of balance. We're gonna write 3 more like this with different words, obviously, and then we're gonna turn everything into symbols. And then do a truth table and we'll see which one ended up being equivalent. Okay. For B, we have the tire is not out of balance. Or the tire is not flat. For our C statement, or C, the sentence that they give us, is the tire is not flat. And the tire is not out of balance. I'm gonna have to zoom out, y'all. For D, last statement, if the tire is not out of balance, then the tire is not flat. So when you see a problem like this on the homework and it just asks you a sentence and it gives you 4 other sentences, you need to go ahead and say, what is your P? What is your Q? Right? You need to put the original, which would be the one written in black, symbolically. Then you need to symbolically write A and then B and then C and then D. And then we're going to create like a little truth table answering all of them. And then you compare the actual answer columns. Peter's excited. Excuse me. Okay, so this is how you work on it. I probably need to zoom out a little bit more, and that maybe that might be all I need to. Y'all have it written in front of you, so I might end up having to cover things up. Okay, so this is how you do it. I'm gonna go to, we have like a dark blue. We've never used dark blue before. Okay, so this is what we do. What we're gonna do is we're going to let P be the simple statement. You want to like exclude the negation from that, what they give you. So whenever you read the like black actual like given statement, it says it is not true that the tire is both out of balance and flat. So what I want to do is I want to take the 2 different things that are being said, that the tire is out of balance and that the tire is flat. Okay, so we're going to let P be the tire is out of balance. And then we're going to let our simple statement Q be the tire is flat. The tire is flat. Okay, so we're going to call this right here. I'm going to call it my OG statement. It's the original. You can write original. I wrote original, but I put OG right here. That's my original statement that they gave me. Okay. And so if I actually think about my original statement using the P and the Q that I have, let's write that symbolically. Okay, it says, it is not true that the tire is both out of balance and flat. So it is not true, or it is false, that the tire is out of balance and the tire is flat. That is actually symbolically what that original statement is saying. And I don't know if y'all have room to write next 2 things, so I'm just going to keep going down because then I think that makes more sense. I can move my screen around. Y'all can't really add more room to your paper. Okay, so that's my original. Now let's talk about my A statement. And remember, I'm using these as my P's and my Q's right here. Okay, now if I use that for my P's and my Q's. I got some keywords, don't I? Okay, so I have the word if, then. So that tells me it's a conditional, which means it's gonna have that one-sided arrow, the one arrow that points to the right. And then I'm sorry, then I see right here, not flat and not out of balance. Those are my keywords. Okay, I have if, then, which is an arrow, not flat, not out of balance. Not flat is the first one. Okay, so because I see that, because I see the if, then, that was the conditional that we learned about the other day. It starts with not flat. Flat is Q. So not flat is not Q. And then after the word then, it says, bless you, bless you, bless you, not out of balance. Out of balance is P, so not P. Now for my B statement, I also have keywords. My keywords here would be not, or, and not. So let me write that symbolically. The tire is not out of balance, which is my P. Switch into my black, not out of balance, or not flat. And it's a minute. Well, actually, since I already kind of changed it, I'm gonna scooch up just a little bit, okay? Like that. That was me doing the B. I found those keywords. Now for C, I have keywords here as well. The tire is not flat and not out of balance. So when I look at my statement, the tire is not flat. That's Q, not Q, and then not out of balance. It's kind of everything that we've done in 3.1 or that we did, but like in a bigger problem, needing to do it like a lot just to get to a final answer. Why doing this is fun. Okay, so if, then, that tells me conditional. If the tire is not out of balance, the tire is not flat. Those are my keywords. Okay, so if, then, there's my arrow. The tire is not out of balance. That's the first statement before the then. So that would actually be not P. And then it's followed by tire is not flat, which would be not Q. And they're asking me, out of these statements, this original and all of these, which one is equivalent to it? And so what we're gonna do is, I wonder if I called it something. No, I didn't. I just said truth table for all 5 statements. The good thing is it's just a PQ, and you'll notice that it's really not gonna be, what? Stop. Okay, so let's do this. Watch. Let me actually, I like it better when it's like, okay, I'm gonna do P, Q. Then we have the original. And then we're going to have A. And then, and honestly, if you wanted to just write ABC, you can, but it's hard to keep up with it sometimes. And then we will have B, and then C, and then B. A PQ is true, true, false, false, true, false, true, false, and then we can start answering. Yeah. Okay. So for the original statement, after a while, if you've done these enough, y'all, like, and haven't just not been doing the work, you will start seeing patterns and you don't have to do every single thing. But for the original statement, which is the 3rd column right here, it's an and then it's been negated. So if you do the and here in your mind and then just write the negation, then you're done. But I never know who knows and who doesn't, so we're gonna do all of it. Okay, so for the and, is T and T true? Yes. T and F? No. F and T? No. F and F? No. The negation flips it, right? Then I'm gonna go ahead and I'm gonna circle that because that is the answer column for our original statement. And then we're gonna do the same thing we've been doing. Let's negate Q, negate P, answer column in the middle for the second one, for B right here. So if I negate Q, that's F, T, F, T. If I negate P, that's F, F, T, F. Oh. F, sorry, I said that wrong. F, F, T, T. Mm-hmm. Okay, so here's the parentheses. And then, oh, thank you, Peter. You stupid. Hold on. Let me erase that. When I start talking, y'all have to catch me if I mess up. F, T, T, T.
Not what I was gonna ask, but
Oh,
okay.
hey, you caught a mistake and you didn't even know it. Okay, so the and, they both have to be in order to get a T. And then the negation was right here out in front. So that's why I negated it. And then I circled it with the highlighted pink.
So on the end, it's
Both at the exact same time. That's the only way you get T. The or is either or both. It don't matter. And then negate Q is F, T, F, T, negate P, F, F, T, T. Now the answer column, this is the lottery, right? If I did not play and I did not win, I cannot be mad. T to F, that's the only time you get F. F to T is fine. T to T is fine. That is the answer column for that one. So right now I can tell that, here, I'll write them right here, y'all. This is OG, this is A, this is B, this is C, this is D. Right now I can tell that A is not equivalent to the original statement. Okay. And then if we do B, we're going to negate P, which is F, F, T, T, negate Q, which is F, T, F, T. And now we're going to do an or, which is either or. So is F or F true? No. F or T? Yes. T or F? Yes. T or F? I'm sorry. T or T? Yes. And then what do you notice right here? That one ends up being equivalent. Now it's up to y'all. You could do C and you could do D, but in the homework, there's only one answer. So just as a heads up, you do the same work. You have to change them into symbols. Go ahead and set up a little table. The moment you find the one that works, you're done. There is no reason for us to have to do these because there's only one bubble that can be filled in on the homework. Okay, does that make sense? Okay. So I'm going to move on instead of continuing to do them because once you find it, you're done. Okay, now you can do this or you can actually use this law to state that they are equivalent. And this would be my goal. Instead of having to do, excuse me, and it's not for every single set of statements, okay? But instead of having to do the truth table, where my arrow is pointing, where you've written it A, B, C, D, from this point right here, you should be able to tell whether or not they're equivalent. And the reason why is because it is a law, and it is called De Morgan's. Okay, so hold on, let me write this real quick. I did write this as like a final answer column. I said, therefore, this was the original, right? That it was equivalent to this right here. And honestly, recognize this pattern because this pattern is the law that I'm going to describe to you. And if you can change them into symbols and see this pattern, you can just immediately say they're equivalent. You don't have to do the truth tables. Okay. Sometimes a lot of people completely forget that there's this law that they can state, yes, by De Morgan's law, these are equivalent. Okay. And that was an example of using De Morgan's law. So let me show you and tell you what it is. I didn't think y'all would see this until logic, but apparently it did show up in sets because all math has a connection to other math. But this is what De Morgan's law of logic states, or laws. It's for any two statements P and Q. And when you say and, you can do a comma, y'all. Any two statements P and Q. The first law is if you see this form where it is false that P and Q, which is what our original statement was, it is logically equivalent to, always, no matter what, it's been proven, the conjunction of the negations of both statements. So it's almost like that negation gets distributed inside of that parenthesis right here, but the connective, do you notice how it flips? Okay, so if you have it on the outside and we have an and, its equivalent statement or a equivalent statement to it would be where they're both negated and my and changes to an or. This is something that should be written on your note card, okay? Because this is a form that if you see this, you do not have to do the truth table. You can say, yes, by De Morgan's law, these are logically equivalent, okay? The second one, very similar. If we have the negation of the conjunction of two statements, I wish I had candy because I'd throw it at somebody who wanted to just try their hand at what it would be equivalent to.
PBQ.
Do it again
And Q. Oh, yeah.
and negate both of them.
That's what I said. I was clearing my throat.
Negate both of them and the connective changes.
I'm calling it B because when I typed it in.
Is it? Well, technically, yeah. Well, it's like a regular V and an upside down V. They're both the same. But yeah, that's what changes here is instead of it being negated on the outside and they're both, you know, just kind of simple statements here, they're now both going to be negated. And then if you notice the connective switches, it goes from this to this.
All the same.
And honestly, like there's a way to kind of combine both of these rules and be like, hey, you should understand what's happening. But instead I break them apart, right? So if you have the negation of the conjunction of two statements, it is equivalent to the disjunction of their negations, right? And then the negation of the disjunction of two statements is equivalent to the conjunction of their negations. Yes. And so that's the thing. That's what I'm trying to say. Like a lot of them, y'all, I don't want to lie because my math lab, it just loves making me lie. I think we're arch enemies. I want to say every single one that's set up in this manner that you're going to see on your homework, if you just change the original into symbols, if it says an and, right, then what you're looking for in your answer is the word or. Do you see what I'm saying? Like it literally all of those want you to use De Morgan's. So it's going to give you all the options that are not. You're trying to find the one that does match this form. And it really shouldn't be that hard.
So it only applies to the negation.
So and the fact that it's going both ways, they could do it. I could see them doing it. It could give you this. And if it wants to know what's equivalent to it, it would be that it is false that this and this. It is not true that this and this. It can start on the right-hand side and go to the left. It's just however you write it, it doesn't matter. These are pointing both ways. This means equivalent. And if this equals this, then guess what? This equals this. You can start here and go here and vice versa. So just pay attention because any of the ones that literally look like that whole setup we just wrote paragraphs about, it's going to be like, figure out what they're giving you originally to know what you're looking for symbolically. And then you should be able to read the words and know, hey, I need them both to be negated and I need that and to turn into an or. That's really it. Okay. But if you do get stuck, y'all just let me know. Okay. So last page, last thing we learned over logic. Okay. The whole page. So, let me see. Still going along with the equivalent statements. Our conditional statement that if then actually has like different variations that you can do to it. There's going to be a lot of words here that I say that might not make sense, but I'm hoping that after a while they will. So let's go and get started. We're going to call them conditional variations because we're talking about our conditional statement and its variations that you could see. You will be asked to read a sentence and it'll say to write, like all of the different variations. So you need to know how to change them. So, no, I have heartburn so bad. That hurts. It's like a dragon breathing fire right now. Our conditional statements are what? If P, then Q, right? Oh, goodness gracious. That's like the OG. That's the mother of, that's the parent statement. That's how it begins. That is a conditional statement. Now let's talk about the different variations of conditional statements. The first one that we have is called a converse. I'm sure 9 out of 10 people just thought of shoes. And if I wear the same shoes you wear, it's not uncommon for you and me to like switch shoes, right? So when I think of converse, I think of like switching. The converse variation of the conditional is if Q, then P. And let me write this here, y'all, because I do want to kind of keep my notes as much the same as possible. This is the conditional, right? And it is read if P, then Q. This one right here would be read, just to kind of keep everything the same, if Q, then P. Because if you notice, what happens is that they swapped. I want to tell y'all these words, but I don't know. I don't want to confuse anybody. I'm going to say them, but we're not going to write them. If you do end up seeing these words on the homework, then maybe I failed you. But the first one in a conditional, this is called an antecedent. And then the last one's called a consequent. So what I have in my notes is swap, antecedent, and consequent. But hopefully it's just kind of writing them in this way, right? We can do like a little extra added note in blue and say like they swapped or they switched positions. Okay. Because that's what happened. They like switched positions from like where they originally were in our like parent OG conditional statement. If you do see notes somewhere that say antecedent and consequent, it's one follows the other. Okay, so the other variation that we have is called an inverse. Now with an inverse, what we do is they're going to stay in the same position, the P first and then the Q, but they both are going to become negated. So instead of if P then Q, we have if not P then not Q. And all of this can also be written on a note card. And all you really have to write is this part right here. Well, I would write the original, obviously, right? And then you write converse and then write that form that we have written there. And then when you write inverse, you write that form. Because similarly in the homework where it says write the converse, the inverse, and the contrapositive of the statement on the test, I have to ask you the same thing. So if you have these forms written down, you can take these crazy sentences that I use and you could actually put them into these different variations, okay? Okay, so what happened here is they were both negated. Both statements negated. And if you notice that one, I don't have like a shoe story or anything like that. Converse is the only one that's ever really made the most sense. Inverse, they stay the same. Kind of, you invert them, you do the opposite, because that's what an inverse is, right? Like the opposite. So they are staying in the same position, but you're like taking the opposite of their truth value, which is why you're negating them. Okay, and then the last one, as far as the variations are concerned, is a contrapositive. And I have a very untechnical way of remembering this one. And I know that there's an actual technical mathematical way that my professors in school would have been proud of me, and I don't know that way. So contrapositive is the most complicated or difficult word to say out of all of these. And so you like do the most complicated steps to it, or like the hardest stuff. You're actually going to do both. You're going to negate them and you're going to swap them. Okay, so it's going to be not Q, then not P. If not Q, then not P. Most complicated word deserves the most complicated work. Okay, and this one is if not Q, then not P. And again, right here, the word converse with the form, inverse with the form, contrapositive with the form, that can be written on your note card. Okay. You do not have to remember this at all by heart. But there will be some kind of sentence like what we're fixing to do now. I'm actually going to give us an example, and we're going to write the converse, the inverse, and the contrapositive of this sentence. And that would be similar to what you would see on the exam and on like the homework whenever you do it later. I really do feel like I'm like on the struggle bus right now. Okay. Let's do an example. And then this example ends today's class as well as chapter 3's material. And then what we're doing for exam 2. Okay, so what we're going to do is we're going to let the simple statement P be, I study my homework. And we're going to let the simple statement Q be, I pass my math class. So once they give me simple statements, I can now write the like parent just conditional statement, then the converse, and then the inverse, and then the contrapositive. Okay, so the conditional is just if P then Q, converse is if Q then P, inverse is if not P then not Q, contrapositive is if not Q then not P. Okay, so we're just going to be adding the words not and then if and then to these statements where appropriate. Okay, so let's do that. Okay, so let's start first with our conditional, which we know to just be if P then Q. And that is going to literally start with the word if. And then P is I study my homework. So if I study my, I'm shortening it just to HW. If I study my homework, then I pass my math class. That's the original, right? That's just writing it as a conditional statement. For our converse, which is what? If Q then P. Somebody want to say what that will be? If Q, what's Q?
I pass my math class if I study my homework.
If I pass my math class, then I study. Still use that if then, always if then, always if then.
Oh,
Okay, so let's start it. We're gonna do if, and then Q's first. So if, and just write Q, I pass my math class. Comma, then, because that's how we've always written our sentences, right? Then, and then now it's just the simple statement P, which is I study my homework, which TBH, that makes no sense and is backwards as hell. If I pass my math class, then I study my homework. Do you see how it was simpler than y'all wanted to make it? I'm gonna go ahead and kind of cover up right here and I will switch to purple. Let's do our inverse. Our inverse is where, inverse means opposite. They're gonna stay in the same like direction or like, I'm sorry, same positions. But what we're going to do is we are going to negate them because that is the opposite of their truth value. So literally where I wrote the conditional, you're just gonna add 2 knots. Okay, but I know that logically you wouldn't say, let me see how I wrote it. Inverse, I said, it's not if I not, it's like if I do not study my homework, then I will not pass my math class. There's some kind of logic as far as English is concerned. But did you see how I negated both the P and the Q, but kept them in that same order of P and Q? That's going to be how you write your inverse. So we always start with if because these are conditional variations, right? If I, it's not P. So if I do not study my homework, oh, if I can spell that, I mean, maybe it might help, who knows? Comma, then, because these are all conditionals. It starts with if, after you do your, the one, remember I told you all the antecedent, you then do your comma, and then it's followed by the word then, and then the consequent. That's where those words come from. So then, what is it saying, not Q? Q is I pass my class, so I will not pass my class. If this is not a true statement, I do not know what is. You cannot pass a math class without doing homework. If I do not study my homework, then I will not pass my math class. I do need to cover up everything except for, oh, maybe not. There we go. I think I could do that. And what was the last one? The last variation is, yep, if I do not pass my math class, then I will not study my homework. But what you just said, it's the same thing, but you do want to stick to the simple P and Q statements as much as possible, but obviously don't completely break English. If you do on a test, if I could still understand what it is you're trying to say. If you put the not in the wrong place, like I should be able to tell, but like exam 2 is a lot of truth tables and a lot of this, writing all of these different sentences. Like I give you like 3 lines, 4 lines, 5 lines to actually write all of these variations. Contrapositive. Contrapositive, most complicated. You do both. Okay. And then Peter did say it, but this is saying that I'm negating my Q, and my Q is I pass my math class. So if I negate it, it's if I do not pass my math class, then I will not study my homework. Yes. Just make sure, because it is a conditional, it's always if you write that first statement that goes to the left of the arrow, do a comma, then write then, and then you write the second statement, the same way we've been doing, but you definitely want to like be proper with that. Like the comma is important. The words if and then are important. Like those are little things that get marked off -1, -1. So you don't want to do that. So if I do not pass my math class. Okay, that was the antecedent, comma, consequent, then. And the if then is what makes it a conditional. Okay, you leave that off, you're really not telling me a conditional statement. Then I will not study my homework. I think a lot of people have had this happen before, and then from that point forward, they do not do their homework because they don't think it helps, and then they fail again. Does that make sense, y'all? Because that was it. Yeah, kind of a lot, couple of different definitions. The going from sentence form to symbolically is very 3.1-ish. The De Morgan's law is a shortcut, right? Turn it into symbols and be able to find it. And then that last page, thank you so much. The last page was a doozy, but remember what you can and cannot have on your note card. Y'all are free to go. Unless you have questions, obviously I'm here. Just saying, I'm gonna turn this off. Okay. Remember Thursday is an